So good morning everyone and welcome back after the short tea break for the session on the course on climate change and urbanization organized by the Department of Architecture and Planning and Department of Civil Engineering, Managed Bhopal by Dhyan and Ministry of Education. For our next session, I feel honored to invite on stage on the dais our foreign expert and faculty of the course, Professor in the Department of Meteorological and Climatological Research at the Royal Meteorological Institute of Belgium, Professor Ravi Ghani. Welcome.
Thank you very much. So, everyone, welcome back to my. So this is my third lecture about. If you remember, the first one was about general introduction of climate change. So how do we do climate modeling and how we do climate observation. The second lecture was about what is the status of the climate change from the IPCC report. And we heard that this morning from Dr. Sharma how the IPCC report is very important for them because they use this as the solid science to make all their decision and all this, all their transition. So now, what this lecture is about is, in fact, what we did. We tried to extract from the IPCC report. The IPCC is really a huge report, so it's thousands of pages. So the IPCC is divided into 3 working groups. You have working group 1, dealing with the physical science, okay? So like the climate, how the climate will change. So it's more physical, temperature, precipitation, is the physical aspect of the climate system. This is working group 1. You have working group 2, which is dealing with the impact. What is the impact of climate change? So what is the impact on human? What is the impact on ecosystem? What is the impact on all the kind of impact that climate change can affect? So this is the impact and adaptation, of course. How, for example, and this is important for this lecture, is how we should adapt our cities. On Thursday, we will start to see this, how do we need to, what are the solutions to our city. So this is working group 2, okay? And then you have working group 3. What is working group 3 is dealing with the mitigation, how to reduce the emission. So we heard this morning from Dr. Sharma, all the things that the companies are doing to reduce the CO2 emission. So you should put in your mind, so it's different. The mitigation is reduce CO2. Okay, like you can use solar panel. If you use solar panel, okay, then the electricity will be renewable electricity. So you don't use fuel, you don't use to make electricity. So this is mitigation. You mitigate, you reduce the CO2 emission. Okay, so these 3 working groups, and what we did here is that we extract the information from these 3 working groups. So every working group has their own report, which is around 1,000 pages. So it's very difficult to catch the information related to urban. So we extract the information, especially for the urban part, from working group 1. We extract it from working group 2 and also from working group 3. Okay, and this is, and I put all this together for this lecture here for you. Then you don't need to go to each report. You will find the information here for about the urban area. So this is the what the latest science on climate change means for cities and urban area. Okay, yeah. So this is just what I said. So I told you we have the working group 1. So we extract the information, what the latest science from the working group 1. We extract the information from the working group 2, and we extract the information from the working group 3. So we have 3 small reports, which is dedicated to urban area. And this was done, we call this a summary for urban policymakers. So in fact, it's a report dedicated to policymakers, urban policymakers, where we extract all the information from the assessment report number 6. Okay, so you know, now we are in the assessment report. No, this is the old, let's say the previous cycle, AR6, that now we are just starting, the IPCC just start the AR7. So the 7th cycle just starts next year. And just to tell you that the next report, special report of the IPCC will be on cities. So
So we will start the writing of this report next year, okay? In March, we will have our first meeting in March, and then, so 26, 25, 26, and then March 27, this report will be released, okay? So this is a special report on cities, but of course, we will build on what has already been done here. So we will not start from scratch. So this information is from the previous cycle AR6, okay? Okay, so first thing, why we are interested by cities? So why should we care by cities? There is also rural area. I told you yesterday what is the amount of urbanization in the globe. You remember from yesterday, what is the percentage of cities, of urbanized area in the world? I told you this yesterday. Less than 2%, you see? So less than 2% are urban areas. So why do we need to care about this? Because we have all the other areas, climate areas, which are more than the other 98%. They are not cities. But we care about cities because people are living in cities. We are living, a majority of people are living in cities. So the global urban population is currently 4.5 billion and will touch 7 billion by 2050. So the amount of people who are living in cities or who will live in cities will just grow in the near future. And this will lead to a rise in demand for resource, infrastructure, and services that the urban and infrastructure transition could address to limit the emission. So I think the talk of Dr. Sharma was really perfect to give you the introduction. She talked about transition, okay? We need to make a transition. So all this, to reduce the emission, she said, we need to make ambitions, okay? And we need to make targets. We need to go to this, and then we start the transition. So if all these people will come to cities, all these people we need to make building, to construct building, right? To construct road, so all this we will emit. If we construct a new building, we will make a new emission. She really explained this very well this morning. So that's why it's very important to take care of what is happening in cities. Of course, rural area, as it was your question, is also very important. But so here it's really the amount that, and I will show you the slide after. So how we can reduce the new emission that will be released in urban area, because more and more people are living and will live in urban area. So, rapid urbanization, change in land use, demographic shifts, as we just discussed, growing inequality and unsustainable consumption have driven greenhouse gas emission, ecosystem degradation, and biodiversity loss. So this is just what I told you, is that more and more, you are just putting more and more pressure to the system, okay, to the ecosystem, all the ecosystem. And in all parts of the world, this trend poses an existential challenge to our society, economy, and urban area. We need systemic and accelerated climate action by everyone to address this. Urban area provide an important opportunity to do so. So I think it was really very, very well explained also this morning by Dr. Sharma. We need to do this transition. And she explained well how the companies are doing this. We need to do this also for everyone. Should take this into account. And we talked a lot about the slums. This is some example, because these are very vulnerable places. So, and you will see how it can. So we need to take actions. And one thing is that in this climate action that we are taking, no one should be left behind. So we don't say, okay, we will focus only on this area or on the rich people, or no. Everyone should be, we should take everyone with us in this action. No one should be left behind. So it's not a problem of Global South, because as it was mentioned this morning, India is developing country. So still developing, so we need to build a lot of cities. So cities in the Global South, like in India, some are at early stage of urban development, need new infrastructure and buildings, leading to potential high material demand and embedded emissions. So she explained very well how an architect should take into account the climate. She explained really stage 1, stage 2, and stage 3. You remember stage 3 where she said that we need really to take even the building, your new building, and in the surrounding. And if you look from vertical, yes, this building should be within an homogeneous, in homogeneous way within its environment. So all this should be taken, and so we need to take this into account in order to reduce the emission, because more and more people will come. So we need to construct building, road, etc. So we should take this into account. It's not a problem of Global South only. It's a problem of also established cities in the north, let's say. If you look to Europe or US or Japan, or where you have already established cities that developed in the past, the problem is that all these cities, they are now a bit old. Like the city where I am living in Brussels, it's really now, all the buildings are old. So we need to do, it's aging infrastructure, and we need to retrofit the building. So we need to refresh the building, retrofit the building, because a majority of these cities were constructed after the World War II, 1950. And so now it's time to refresh all these cities because it's becoming old. Like, for example, when you have warming, when it's cold and you have the warming, a lot of the heat is just go because of the isolation is not good in all this. So the isolation should be, and this is really one of the biggest challenge in Belgium, for example, is to make all the building very well isolated, because then when you do the warming, when it's cold, the heat is not going out. To really to have, we are also working on passive building, so you don't, passive building where it stays warm, we don't need any warming. So all this is also, so you see that it's not a problem of Global South, it's also a problem of Global North. So it's a global problem, this urbanization. We should take this into account. And if it is unaddressed, this challenge could drive unsustainable emission growth from urban consumption and production throughout the 21st century. Okay, so urban climate change mitigation has a crucial role in determining the future of the global climate. So mitigation, I told you, we need to reduce CO2 emission. So how cities and urban areas are planned, designed, built, retrofitted, managed, and powered will influence urban greenhouse gas emission. You see how important all the urban planning that we need to take into account if we would like to reduce the greenhouse gas emission. And because I did not tell you this, but we know that around 70% of greenhouse gas emission are coming from cities, from urban area. So around 70% of global greenhouse gas emissions. So you see, so cities are very small, less than 2% of the earth, but they are emitting 70% of the CO2. You see, that's why it's really very, very important area to take into account. And a large share of people in low-emitting countries lack access to modern energy and mobility services. Eradicating extreme poverty, energy poverty, and providing decent living standard can help achieve sustainable development. And I think that it was really very well explained this morning by Dr. Sharma, all this aspect of extreme poverty, energy poverty, and how we should take, and also the question that was asked by from the difference between urban and rural, how we should take this into account for all this aspect. Okay, so here I will come back to my physical background, because I am physical background for the climate. So what I put here, so this is a map that shows you the urban expansion, okay? So this is the urban expansion. It's by 10 kilometer by 10 kilometer grid, and it is from 2000 to 2020. So we have like 2 decades, and we wanted to know how much the cities grow during these 2 decades. Okay, it's 20 years, 21 years. So India is here. What we found is that urban land in India and also China, you can see here how it was urbanized, is the largest in Asia. So with 1.29 10 to the power 4 kilometers square in this period. So you see that The first one was China, but the second largest one was India. So China and India are the two most countries that has urbanized a lot in this two period. And I am sure India will still keep growing. That's why it's very important to take this into account, because it's developing countries. So developing means more urbanization. Developing will mean more cities, more urban area. But we need, as I told you, to take this into account to reduce the emission. Because if we don't do this, we will just increase the emission. And it was really very well explained this morning that we need to take this into account. Also here, urban impervious area in the Middle East, you can see here some Middle East country has more than doubled in some. And I made also the exercise for Africa. And we know that Africa is the least emitting country, of CO2 emission. It's really nothing. But the amount of urbanization has just doubled in Africa. And it will still keep going. So in fact, it was before China and India that are already the process of urbanization is ongoing, but the turn now will be on Africa. So Africa will be the next continent to be urbanized in the next decade. So it's a really also very important continent to take into account for the global emission. So all this future urbanization, what will impact what we call the climate risk. So what is risk? So the climate risk is exacerbated in urban area by the interaction of climate hazard, exposure due to densely populated cities, I told you, inadequate building and basic services, and poor infrastructure, and underlying vulnerability. So if you look to the risk, the heat risk to human health, for example, if we take the heat risk, and I show you yesterday this picture of the number of days more than 35 degrees in India, and we saw together that it was really increasing with global warming levels. So if we take the heat risk to human health, what is this? It's a combination of three things. So you have first the hazard. The hazard, it's meteorological hazard. It's the extreme that we got. So we need to do a hazard reduction. How? To reduce this climate mitigation. Okay? So if we reduce the CO2 emission, of course, we will stabilize the climate, less extreme will happen. Reduced air pollution also, because in all the cities, you have polluted air, so this will also impact the health. What we have also the exposure. So the risk is combination of hazard from extreme that will happen, the exposure, so how we need to reduce the exposure, like for example, increase public green space. For example, during heat, you need to have more green space to cool. We need also to alter outdoor work times, because, I know in hot countries, you cannot work during the hour where it is really hot. So you need to maybe start very early in the morning, start the work outside. I am talking about the people who are working outside. You need to start early morning and then maybe stop during when it's really hot during the day, and then work when it's like late afternoon, because then it's a bit cold. So we need to think of shifting the outdoor work time. So the outdoor work time should be shifted if we would like to reduce the exposure of these people to this hazard. We need to work also on active and passive cooling. And we heard this morning passive, like the ventilation, natural ventilation. So when we are building city, we need to think of this in order to have this passive cooling of course, we need an early warning system, like for example, a system that will tell you when you have, if a heat wave is forecasted for the next days, we need to have this early warning system, and of course also cooling shelters. So we have the hazard, we have the exposure, and we have the vulnerabilities. The vulnerability, like what I show you, the slums. The slums are very vulnerable to this. So it's a vulnerable place. And we heard this morning that India is really ranked number 7 in the world for the vulnerability. So a lot of work should be done on this. So how to reduce the vulnerability? So the livelihood diversification, we also need to work on insurance and public health infrastructure. So this is how we can reduce the vulnerability and also access of these people, like in slums, to green space, access to health infrastructure, etc. So all this should be taken into account. This is what I just showed you in Africa. This is an example of how the climate impact is felt disproportionately in socioeconomically communities. So depending on the socioeconomic level, the impact of climate will be different, of course. For the rich people who have like good infrastructure, they will feel the climate impact differently from slums places. Okay, we will talk about the urban heat island. Okay, so because this is my specialty, so what we did in this report, we wanted to know, okay, so we have the urban heat island. What are the origin of the urban heat island? So what are the factors of the urban heat island? I told you in the first lecture, urban heat island, this is not greenhouse gas problem. Okay, it's not related to climate change. This is related to how you construct your city. So what we did, we checked in the literature, because you know IPCC, you need to assess, I told you, we need to assess a lot of papers. And what we did, so we assessed a lot of papers, and we tried to check what are the origin, what are the reason of this urban heat island. So we divided into 5 factors that create the urban heat island. And the first one you can see here, so if it's red, this is a warming. So it means it will warm your local environment. Okay? If it's negative, this means a cooling of your urban environment. So the first, but I could ask you this before, but now I already show it to you, that the first parameter of the warming is the city geometry. What is the city geometry? Is the building density, the city layout, the height, and the size. So this is the first parameter. So how you are putting each building near to each other, this is very important. This is the first parameter that you see the warming is about 1.4 degree warming locally. I told you, I will repeat it, this is not climate change, this is locally. So you need not to add, it's not linear. You have the climate, we talked yesterday about global warming of 1.5. The urban heat island is the same, 1.3, 1.4. It's the same order of magnitude, like the global warming. So these two, it's not different order of magnitude, it's the same order of magnitude. So it's really very important to take this into account. Alors, the second factor that comes into play, it's what I told you yesterday, is the anthropogenic heat. So I told you this is unique for cities. You don't find this in forests. You don't find this in other land use. You find it only in cities, is all this heat which is going to the atmosphere from industrial and domestic heating, for example. All this, we call it the anthropogenic heat. So the anthropogenic heat is number 2. You see that it's almost 1 degree warming. No? The number 3 is the material that you are using to construct your building. This is really, and we heard this morning about, we need to take into account the material. So if you use local material, that will be much more for the environment. So, because if you use some material that we are using here, this one, it has a big heat capacity. So during the day, when you have sun like today, all this sun, this energy is kept, because you have a big heat capacity, is kept by the wall, by the roof, and this energy during the night is released. Okay, and since it is released during the night, this is what makes your city warmer during the night. So these parameters are number 3. But we were surprised that the number 2 is not the parameter, but is the anthropogenic heat. So you have the city geometry, the anthropogenic heat, and then the material. So if one would think, how should I reduce the local warming of my city, the first thing that you need to work is city geometry, is to create some building, so to take into account how you are putting the building together, to take into account the ventilation, natural ventilation. The second parameter is how to reduce the heat, all this anthropogenic heat, and then number 3 is how to use good material that don't store all this energy and then put it in the night to the atmosphere. So how to cool? So we can use the water body. You can have like sea, rivers. Of course, you have the sea. You have the sea breeze. Okay, the sea breeze that will cool. Like Mumbai, we saw this yesterday. That Mumbai don't have yesterday it was really very well explained that Mumbai don't have a big urban heat island problem because it's a coastal city. So you have the sea breeze which make your urban heat, because then when you have wind, it will be mixed. All this urban will be mixed in the air, so you will not have a concentration of heat into the city itself. So the sea, the river, the lakes, the irrigation also. Irrigation, if you are using vegetation and then you irrigate, this will also make a cooling of your city. And the most important cooling you can see is the vegetation here, like park, forest, and garden. You can see that we can go up to minus 1.6 degree cooling if you use the vegetation. So, in fact, this area here, Hashut area, this is with different climate zone, because I told you we make an assessment for different climate zone, like desert, temperate, like tropical, a lot of climate zone. So, we need to think of a smart combination of city geometry and vegetation. If we could make a smart combination, this and this we can cancel. We can cancel out the urban heat island. But you see, we need to really think of how we could combine in a smart way these two parameters, the city geometry and also the vegetation together. So a smart combination could really offset the urban heat island. So, and what we found is that the combination of future urbanization and increasingly frequent extreme climate events, such as heat wave, will exacerbate heat stress in cities. Because, in fact, what we found also is that if you have a normal situation, it's different than if you have a heat wave. Because if you have a heat wave, and maybe I will also present this later, is that during heat wave, the urban heat island will just be intensified. We found this in some cities. It's not for all cities, but in some, my city, for example, Brussels, where I am living, during heat wave, the urban heat island just gets bigger because the rural area and the urban area behave differently to heat waves. Okay, but I can explain you this later. So, during heat wave, the most important is during the heat wave, because during the heat wave, the urban heat island will exacerbate the heat stress. And we saw this, so it's really a problem here in the tropical region where you have also the humidity. So because heat stress, it's a combination. You can combine temperature, relative humidity. And if you add on top of this the fact that you are in cities, because in a city during the night, you need to add at least 2 degrees, 3 degrees to your heat wave. So it will exacerbate the heat stress in cities. So we need to be really very cautious about how future urbanization will be, because urbanization will intensify the urban heat island effect regardless of change in the background climate. So depending where your city is, if you make your city bigger and bigger and bigger, it will intensify the urban heat island. And I will show you this in the next slide. And this is, I already said that sufficient integration of vegetation and water into the urban fabric can counterbalance the urban heat island effect to the point of even cancelling out the urban heat island. This is, I told you, at neighborhood scale. So we need really to think at this scale, neighborhood scale, of a smart way, how we can combine the city geometry and the vegetation, because this can help really to reduce. Okay, so what we did also during this, in this report is that we checked in the past. So we look into the past of some cities where we have a pair of observation, one observation in city and one observation in a rural area, okay? And in the city, this observation observe how the city has grown in the past, okay? For example, and you see the first thing that you see is that we don't have a lot of cities, because it's very difficult. We talked about this yesterday of the station in cities. It's very difficult to find station in cities. And the most difficult is that if you are lucky and find a station in a city, this station, usually it has not a long time series. This is the problem. And if you would like to study the climate, you always need long time series, at least 30 years, 40 years of observation. And it's very, very difficult. So that's why we have only some cities where we could find such information. So I will talk about my cities and then we can talk about Kolkata. So in my city, Brussels here, so we found that, so we compare. We have one station in urban and one station in rural, and we make a comparison how these two stations change in this period. Okay, the period is here, 1958 to 2018. So we compared the urban station, which grow, and the rural station, which grow, but we found that the urban station during this period grow much more higher than the rural station. So we found that the difference was around 0.6 degree during this period. It means that, because in Brussels now, I can tell you, we are experiencing a warming of 2.7 degree if you compare to pre-industrial area. Okay, so 2.7 degree warming now in Brussels. You see, it's we talked about the Paris Agreement yesterday, limiting 1.5 or 2 in cities, and in majority of cities, we are already above this threshold. So we already overpassed the Paris Agreement. So the Paris Agreement does not make any sense for the cities and the urban area because it's already overpassed. I told you in Brussels, we are at 2.7. So 0.6 from this 2.7 is due to the growth of Brussels. Okay? That's why we put it here. So this is, we call it the urban warming. So how the local warming, we call the local urban warming. So how the city influenced the local warming. So it was 0.6. You see here, Kolkata is one of the biggest urban warming that we found is that you see that the urban warming of Kolkata is around 2.6 degrees. And you need to compare this with, in the map, what I put in the map here is the background warming. Background warming, we take it from this data set, CRU, TS, maybe you know about this, CRU TS. It's a gridded data set that gives you how the temperature increase. But the resolution is quite coarse, so the CRU data set don't take into account the urban. So it's only like background. We call this the background warming. So you can compare, for example, the increase in Kolkata, which is red, with the background warming here over India. You can see that the Kolkata is really increasing much more than the background. So you need, it's not linear. You cannot just add this to this and say, the total warming is this and plus this. It's not linear. It's not that easy. But then it gives you already what is the two different warming that you have. Okay, so we have also here in cities like Moscow and Tehran also here. So this is, so again, most cities and urban area will experience increase in local temperature of 1.5 and 2 degrees earlier than other area. So I told you yesterday, global warming, we are at 1.1, you remember, we are at 1.1. Paris Agreement to limit 1.5 to 2 degrees, but cities, we are already above this threshold. So the Paris Agreement don't make any sense for cities.
Maybe I missed it.
Yes.
This is air temperature.
Yes.
This is surface temperature, right?
No, it's mean surface air temperature.
Surface air temperature
Yes, it's 2 meter temperature.
at 2 meters.
Yes, 2 meter. Yes. So it's not the surface temperature.
It's not surface.
No, it's the air.
Air temperature
Yes.
at 2 meters, like our.
Yes, yes.
So this has been captured through satellite images
No, this is from observation.
from observation.
Yes, from observation. Like here in Brussels, we have one observation, air observation, in the city, and we have another one nearby in the rural area. Yes, and we are lucky that we have these two stations that kept working for all this period. So that's the problem, is that it's very difficult. It's very difficult to find a pair of urban, rural in everywhere in the world. So this is what we could find. But I think that we will make an update of this in the next report, the special report, for sure, we will have more papers that will come, and maybe more cities. We can add more cities here, because it's based on the publication. So these are the publications that we could find, where they put these numbers. But because IPCC, we don't do research ourselves, huh? So we just
This
yeah.
would be one of the recommendations for you to the cities, that we should have at every city and corresponding rural
Yes,
areas
yes.
mandatory from the government.
Exactly.
To install a long-term.
Exactly, and we are just, it's a very good comment, because we are just trying to have this in my institute. We said to the director, our director, look, we need, because for the WMO, we cannot put station in city, but we said no. In order to be able to keep this for a long time, it should be done by institute, by Med Service. So we are trying now to put one in the city center, because then we can have it for long. And tomorrow, I will give you the exercise I will give you one station in the city and another station in suburban. So then you can make the difference and you will see. But we are trying to really to establish one city for a long time, then to have rural and yes, and urban. And if it will be like a recommendation for all that they will follow, that will be really good, because then we can have really for a long time, because this is what we need. The problem is that here you can have a network, but it's done by university, or it's done by, so it needs to be maintained. Sometimes it's related to one project, but when the project is finished, then the observations are finished. We don't do observation anymore. So the only way to be sure that it will maintain is to do it by an operational institute.
Yes.
So that's what we are trying to as a recommendation. So just put in your mind, if someone asks you about Paris Agreement, say for the cities, we are already above the Paris Agreement, and majority of the cities, they are now at more than 2 degree warming, 3 degree warming. My Brussels, it's 2.7 degree warming. So I don't know here in Bhopal, but yeah. Or because of the urban heat island, because the urban heat island add more heat. So it's like the city are advanced in the warming. You see, if for example we would like to limit to 1.5, cities are already at 2.5. So we are already, so the heat wave that will impact the city will be much more difficult than if it impact the rural area, because the city have the urban heat. So it's like it's adding to the heat. Okay, so emission implied by current policy will cause global warming to exceed 2 degrees by around 2050, and even with strong emission reduction, the increase of cumulative CO2 emission will result in global warming exceeding 1.5 in the next 20 years. I told you yesterday, this year will be the first year where we will have 1.5 degree global warming. So observed. So it's the first year where so this objective of keeping, I told you this objective of keeping 1.5 is really, it will be really beyond reach, because of the cumulative CO2, because we already have, even if we decrease, the fact that we have cumulative CO2 emission in the past will not help to reduce to reach the Paris Agreement. So the risk and impact of climate change are clear. Even at current global warming level, urban areas are experiencing significant impact from climate change, and some major cities have experienced mean local warming of beyond 1.5. I already explained you this very clearly, that the cities are already beyond 1.5 and beyond 2 degrees. We can say this. So what we did in my institute, we tried to see, okay, we know that Brussels is already beyond 1.5, but suppose that we will succeed to reach the Paris Agreement. So now I told you we are at 1.1 global warming for the Earth. So suppose that, okay, during the COP, Dr. Sharma speak about the COP, very important, because the COP is where the countries, the parties are trying to reduce, to say, okay, we will reduce our emission to reach this during the COP. So, and you say that you remember it was it's still very difficult because you have all this aspect of financial aspect, which is very difficult. Anyway, so suppose that we will reach 1.5 globally. We are at 1.1. Suppose that we will reach 1.5, 2 degrees. what does mean this for Brussels, for my city? What does mean this for Brussels? So what we did, I told you Brussels now is 2.7 degree. So if we reach 1.5 globally, what will be the temperature in Brussels? I will not explain all the method that we did. It's a bit complicated with a lot of downscaling techniques and the model. But we found that 1.5 means 3.6 to 4.1 degrees Celsius in Brussels, warming in Brussels. This is huge. These numbers are really huge because if you have a heat wave, which on the city of Brussels, with this number of warming, this will be really a huge impact on a city like Brussels. And we are already experiencing in Brussels like a relationship between heat wave and mortality and morbidity in hospitals. It's for vulnerable people. Vulnerable people are really very, they are impacted very much by the heat waves. And we found a net correlation between the admission in hospital, between the morbidity, we call this the morbidity, and also the mortality, and the heat waves in urban area. So you see, this is huge. So that's why I told you the Paris Agreement does not make any sense for cities, because it will have this huge number, and we need to adapt cities. There is no way we need to adapt our cities, and at least to reduce the urban heat island. Try to reduce this urban heat island impact. So we do the same, because I had one PhD student from China, and she worked with me, and we try to do the same exercise for Beijing. So for Beijing, we do exactly the same exercise, global warming level 1.5, 2 degrees, the Paris Agreement, and we found that we come up with these numbers. It's the same numbers for Brussels, but we can do the same exercise here. Huh? We can do the same exercise for Bhopal or for Delhi or Mumbai to see what does mean this for a city. So this, I already showed you this picture, but just to show you that this is India is here. So we have this warming of hot extreme, an increase of hot extremes, increase. So the urbanization has exacerbated change in temperature extreme in cities, in particular for nighttime extreme, and this is with high confidence. This means that these extremes, okay, that we have here, and that we are sure that it's confidence in human contribution, the fact that you have urbanization, more urban, it will exacerbate the temperature extreme in cities during the night. And why during the night? Because of the urban heat island. Because the urban heat island is a nighttime phenomenon. So you have this, you have also during the day, but the amplitude is much more higher than during the night than during the day in the night. So that's why it's affecting really the nighttime. This is the same what we did. But it's for, this is for hot extremes. You can remember here, you can see here India. And this is for the precipitation, heavy precipitation. So we found also that because the temperature, and we will see this later, the cities, the urban area are not impacting only the temperature. They are also impacting the precipitation. We remember yesterday the lecture of Sobimal over Mumbai. We show how the city influenced the extreme precipitation. So the fact that you have city, because you have more, they found that this was due to the more turbulence. You have your city, you have more turbulence in your city, and this will make the extreme precipitation more extreme. Okay? So that's why, so already you have an extreme here, increase, so you need to add on top of this the cities. Why? This is why, because so this is, I think I already said this, that every region will experience concurrent and multiple change in climate impact driver at higher level of global warming. And in many places, these are causing compound event. Do you know what is compound event? Compound event is, for example, suppose that you have a drought, okay, which is a long time, like it can stay for 4 months. You have a drought, okay, or sometimes it's years. Huh? For the region, for the Mediterranean region, you can have it for years, okay? You have drought, and during the summer, you have already the drought, and on top of this, you have heat waves. So this is compound, is that you have already a drought going up, and you have a heat wave. And with more warming levels, this type of extremes will be more and more frequent. And this compound event, the impact of this compound event is bigger than the sum of drought plus the impact of drought plus the impact of heat wave. So because the compound is non-linear, okay? It's non-linear, so the impact is not the sum, it's bigger than the sum. So that's why it's really very important to take this into account, and especially for cities now we are working on the impact of compound event on cities. This is really a new topic of research, so if you would like to publish, that your paper will be cited in the next IPCC report, it will be good to work on this compound event, because it's really big research gap. It's a research gap now, and we are trying to work on this for the next... So I told you why. So the cities are not impacting only temperature, impacting also precipitation and flooding, because when you have heavy rainfall event, I just show you that for example, over India here over India, so we are projecting that it will be an increase. Here you see it's blue, so it's an increase of heavy precipitation. This was observed. So if you add on top of this, and these heavy rainfall are more intense and more frequent in the warming world, projected, because then you have the runoff, which is amplified by urbanization. Why? It's amplified, and this is very clear in cities, because of the impervious area, the water cannot infiltrate. Okay, and then this will exacerbate the runoff. So you have here that the runoff is amplified by urbanization, and heavy rain event can flood buildings, of course, roadways, subway, tunnels, and farmland. And heavy precipitation may overwhelm city transportation and storm water drainage systems, which are typically not designed for climate-induced extreme events. I will explain you this, because the problem is that I told you, the cities, for example, in Belgium, or the cities were built in 1950. 1950, we don't know about climate change. So all the design of the sewer system was done without taking into account the climate change. So we take, for example, an extreme event that will happen in 100 years. We call it the return period. So, and we build the sewer system based on this extreme event that will return in 100 years. But now, these extremes are more extremes because of the climate change. And this is why the design, the sewer system that has been designed is not suitable. Because you are getting some extreme events which are more extreme, and then the amount of water that need to go into sewer is much more that your sewer system cannot absorb it. This is the problem of... So that's why when we are building now new cities, we need to take into account the climate change also in the design of the sewer system. And so this is really related to hydrology, and I don't know if you know about EDF curves. So these are the type of curves that we need to update, taking into account the climate change. Yes, and also very important for coastal cities. So the coastal cities will experience, and we saw this yesterday, Bombay example, the coastal cities are very vulnerable also to the climate change, because when you have storm coming to the city, coastal city, usually you have also you have this problem of sea level rise. You know that I told you sea level rise, which is going on. So you have the sea level rise, so the sea level increase. You have the storm, you have flooding. So this water cannot go to the ocean. So the water will be kept in your city, and it will add a lot of with the coastal flooding, with the potential risk for mortality and damage. It will cost a lot of damage to your city. So that's why coastal cities are very, very important. And I know that in this special report that will come, we will also focus on coastal cities. Very, very important topics, coastal cities. So urban areas are not affecting only the temperature with the urban heat island. I explain you the urban heat island. It's also affecting the precipitation. So this is a very nice review by Dev. Maybe you know him. He's working in US, but he's Indian, and he's PhD student in 2019. And what they did, So they try to see, okay, so if we have a storm coming, this is your city, okay, here. If you have a storm coming this way, how much of rain is over the city? How much of rain is downwind? We call this downwind of the city. And what we found is that the fact that you have a city here will impact the precipitation. So you have more precipitation over the city by 16%. Look to this number. This is the mean, 16% of precipitation more on the city. And then, but downwind, we found even more. So 18% of precipitation downwind of the city. So the fact that you have a city will impact the urban heat island, but it will impact also the precipitation. We saw this yesterday with the presentation of Sobimal, how when they add the full representation of city, they could retrieve the extreme event correctly with the urban. So he showed this yesterday. Because of this impact, because the city impact also the precipitation. So there are different reasons. So Sobimal showed this yesterday, why the city impact also precipitation, because first is the urban heat island. The urban heat island, so create what we call an urban breeze. What is urban breeze? So if you have your city like this, it's warm, then you are creating a circulation over the city. This circulation is due to the urban heat island because your city is warm. It's like the sea breeze, you know sea breeze? Sea breeze, when you go to the beach, you have a wind coming, even if the clear sky is clear, so there is no, but you have this wind because it's circulation, local circulation between the sea and the land, and you have this circulation. It's the same for the city, so you have a circulation like this. So the city is here, and you have circulation like this circulation. And if you combine this with the convection, so if you have a storm coming, this wind will feed. So it will maintain, if you want, the convection, and during the afternoon, it will create more precipitation. And sometimes it's over the city, sometimes it's downwind of the city. So you have this circulation. Another reason is the aerosols. I explained you this yesterday, the aerosols, and also Sobimal showed this. So city, you have more aerosols because you have industry, you have all the activity. So these aerosols, if you have more aerosols, of course, you will have more precipitation because these aerosols are the nuclear for the precipitation. I show you this. So it will create more precipitation. Some people in some studies found that if you have more aerosols, this will decrease the precipitation. So it's still a debate, but we know that these are the two reasons why. And the third reason, of course, he also showed this Sobimal yesterday, is about the roughness of the city. Because if you have city, so the wind will be reduced because you have obstacle, but you create these eddies around the cities. Okay, so these eddies, it's turbulence above the city, and this can also interact with the convection that will. So you have three parameters, three factors that influence the cities, the precipitation. But put in your mind, the city are not affecting only urban heat island, so they affect urban heat island. You have also what we call the dry island for relative humidity. So the city normally you have less relative humidity than the surrounding, okay? Because you have less vegetation in the city. The city, you have also more pollution. We call also this the pollution island. Now you have pollution, but the city also affects precipitation. So you see, city affects a lot of parameters. Yes. So the future change to our climate and how they affect us depend on the choice we make in our cities and urban area today. Our climate is our future. I will explain you this. Why? So what is the length of climate change? We are talking about 100 years, right? So from now, 100 years. What is the time scale of building? When you build one building, how long it will stay? At least, or 100 years. So it's the same time scale. So we are talking about the same time scale between climate change and building when you make a new building. So they are all interacting at the same time scale. So that's why if we would like to have a building which is resilient to climate, you need to build it now correctly because it will stay for the same period. So that's why we say that You need to act now. Dr. Sharma explained this very well, that the action should be taken now, the ambition should be taken now, if we would like to reach all the targets. So the science is clear that cities and urban areas are source of climate forces as well as site of innovation and implementation of adaptation, mitigation, and sustainable development. So I told you all the emission, majority, 70% of emission are from urban area, okay? But urban area also are impacted by the extremes that are coming from the, so, and we believe, and this is what we will also explain in the next report, is that all the solution, not all, but we have solution in cities. So we need to, and we will see this in the next lecture, how we can adapt our cities. So we have solution, there is options how to adapt the cities, and we need to work on this. Both adaptation and mitigation. For example, the solar panel. Now, a lot of cities are using solar panel. You can use solar panel and then you reduce your CO2 emission, but I will show you that solar panel can also impact the urban climate because there is some interaction with the temperature. I will show you this. It's the work of Ansar, yes, that we did. So what do we need? What do we need? I told you, we need the first thing, we need observation. And tomorrow I will talk about the observation. So it's not problem of Global South, it's global problem. We don't have enough observation in cities and we need to establish this. So we need to convince the stakeholders that really we need observation. So this is an observation that we put in the Ghent University. So it's done by university. Huh? What do we need? I will not enter into detail, but I told you, global climate model, they don't care about the cities. The cities are less than 2% globally. We don't care about, they don't have any parameterization for cities. We need to have such kind of parameterization, and I will also show you this after, in climate model. Climate model should represent the city at least with this type of scheme, because then you can see, you can reproduce the urban heat island, okay, with this type of, but I will not enter into detail. So what, and here I put the different type of models that we can use for city. You have what we call the descriptive model. So this is scientific value, and here the complexity. So these are not very complex. It can be like statistical regression. Okay, you say, okay, I will make a statistical regression. It will tell me description of how some parameters are related to other parameters. We have also predictive model, like the climate model, like we do projection. These are predictive, so you will see what will happen in the future, like weather forecast. This predictive model. So this will give you what will happen to your city, okay? But we have also diagnostic model. Why does it happen? This is very important. Why it happen in this way? For example, if you use machine learning now is very trendy. A lot of people use machine learning, AI, but AI will not give you the physical why it is. It will just give you it's this, and it's correct, it's this, but it will not give you the physical why it happened like this and not like this. You just train your machine learning with observation, and then you apply it. So it will not give you. But physically based model, they give you this. Now I know that they are also working on physically informed machine learning. So it's a machine learning, but you can also inform the machine learning with the some physical equation. And the most important one that also is good for the cities is to have these prescriptive models. How can I make it happen or not? What does mean this? For example, I have a model and I say, okay, I will put green roofs. So what will be the impact of green roofs on my city? So this is what we call the predictive model. So it's very good scientific value, but it's also very complex. So it's sometimes you need some input, but you don't have all the input that you need. Very important. It has been shown many times yesterday and also today. We need to work with decision maker. So I told you it does not make sense to work on your, and then to it's not the top down, and then you go to the stakeholder and say, okay, I have this. You need to use it. It does not. It's not working like this. You need to do this co-production of information. So you need to involve the scientists and end user from the beginning and iterative way. You do it different. I think Subimal showed this very well with the map, the app that they developed for Mumbai. So he said iterative interaction with the stakeholders and all the user of the app that he shows. So you need to work like this. It's really changing now. Okay? It's a key for the success of your modeling of any climate action. You need to involve the. Voilà. So I think this I will skip because I will talk about this. It's for the adaptation for cities. I will talk about this because I think it's finished, yes. So this I will talk, all is about adaptation. I think it's okay, we will talk this on Thursday about the adaptation. This is just the author that participated to this. So maybe you might know Aroma Revi, he's also very known. He's working also on climate in the IPCC, and he was the coordinator of this report that we did. Voilà. Thank you very much.
Any quick question, or we'll wait for lunch then?
Okay.